Good morning. Welcome to a spring day here in beautiful Colorado in the shadow of Longs Peak. We're going to do a demonstration video today of setting the nodal point using the Gigapan, Nodal Ninja, and Really Right Stuff nodal heads. And so hopefully we can help you to understand how to properly set up those nodal points as we go about this demonstration. What I have here is the Gigapan Epic Pro set up with Canon 5D, and right now I have a Sigma 24-70 lens, and I've done the early setup of it. I've set the vertical point here to the point where the center of the lens is centered on the center of rotation that the Gigapan rotates on here. I've also set it so that the camera is centered about the center of rotation here. So the next step is going to be to identify the point where the nodal point exists as the camera is moved fore and aft in the slide on the Gigapan. As most of us have learned, the nodal point that the lens has depends a lot on the zoom setting. Or if you're using a fixed lens, a prime lens, you will find that that nodal point is in a specific spot for the prime lens. And it's important to find that out before you start shooting your Gigapans, because if you don't, your stitching will have incontiguous lines in it, especially if you're shooting in an area that has a lot of horizontal, vertical lines and so forth. What I've done is set up a target. And on this target I have a vertical dowel rod with a sharp point, and I also have a target back here with a vertical line on it that allows me to identify as the nodal point moves relative to this point here on the dowel rod to the target. Now, it's certainly possible to do this same kind of a setup using only a vertical object in the near foreground and something in the further background. This happens to work out well because with having the two objects about 5 feet apart, it gives you the ability to see the movement very readily. It also will work if you was to line up this dowel rod with something like the mountain in the background or the tree or a fence post or anything like that. But I've found that it works really nicely here. So I've built this jig, simply a 1x2, about 5 feet long. Got a hole drilled into it for the dowel rod, and then I've also got it set up so I can mount it on a tripod. And I've just got a 1/4 20 threaded insert, 3/8 1/4 20 insert threaded into the 1x2, and then I've got the target cardboard with the lines drawn on it so we can see that. On the Gigapan Epic Pro, we have this slide with a thumb screw that allows us to loosen the screw and move the camera fore and aft to find the ideal nodal point for the particular lens and camera setup that you're using. These are gradiated in millimeters along here, and it allows you to adjust the camera fore and aft position. Likewise, the Nodal Ninja and the Really Right Stuff nodal heads have a similar adjustment that allows you to move the camera fore and aft and find that ideal nodal point. I have my camera set up with the target dowel rod approximately 5 feet, 6 feet away from the camera itself, and that puts the cardboard target about 11 feet away. I've got the ISO set to about 100, the aperture set to f/22 to give me maximum depth of field so that I can see clearly the point of the dowel rod plus the vertical line on the far target. You want to play with your f-stop and your ISO, and hopefully you've got a live view in your camera, which will allow you to actually watch the screen live as you're doing this. If your camera does not have live view, it has a button usually on the side that allows you to check the depth of field at the f-stop that you're set to. You may have to do that if you don't have a live view capability on your camera to actually allow you to see clearly both the end of the dowel rod and the far target. This would even be more exacerbated if you were using just a near target and something in the distance like the trees or the fence posts or something that you might be using as your far target. The greater the distance between the near and far target, the more depth of field ability you have affects your ability to see the motion very finely. And what I like to do is get the target perfectly centered in the screen. So I'll adjust the vertical and horizontal until the target's nicely centered in the screen. And I'm talking about the near dowel rod target. And then I'll move left, pan right and pan left until the dowel rod is very, very well centered on the screen. Using one of these viewfinder shields for doing video work is very handy. It actually magnifies the viewfinder so that you can see even more detail in an outdoor scene like this where there's a lot of light on your LCD screen. It actually helps to be able to actually see clearly. So I'm going to start recording on the camera here, and if we look through the viewfinder at this point, we will see that I've got the dowel rod very, very well centered on the far target. If I pan to the left, right now, just my initial setting I made of the position of the camera fore and aft on the slide actually seems to be very close to an ideal point for this particular zoom setting on the camera. If I pan completely to the right, the dowel rod, as you can see, still stays pretty well centered on the vertical line. I'm going to return to center here. So we're going to try to experiment here and determine what direction the dowel rod is going to move relative to the far target there as we make a pan on the camera. We've currently got it set up perfectly on center so that the dowel rod is centered on the far target's vertical line. As I pan to the left, we're going to look for the direction that the dowel rod is going to move. And we see that as soon as we start panning to the left, the dowel rod moves to the right. Likewise, as we pan all the way to the right, the dowel rod is moving to the left. So from this information, we can start to derive a rule of thumb that if the near target moves in the opposite direction of what you're panning, in other words, if I pan left and the near dowel rod moves to the right, that means that our center of rotation that the camera is rotating on here is behind the actual nodal point, which tells us we need to move the camera backwards. I'm currently set at a zoom of 24 millimeters on this lens. I'm going to adjust the position backwards some and see how much of an effect we have on that. I'm going to move about half of the overall travel of this slide that I have available to me here. We'll center up on the target again here in the center of the screen. Now we look at the target relative to the far target, and I'm going to pan to the left. And what we see is it still moves to the right when I do a left pan. And as we go to the right pan, it moves to the left, telling us that the nodal point is still ahead or forward of the center of rotation. Our center of rotation is right about here right now. It means that nodal point's still somewhere out in this region. And so we're going to have to move further out. So panning to the left a little bit so you hopefully can see this on the camera. I'm going to slide this all the way out to the maximum travel of the slide. So now we've moved the center of rotation further out on the lens here to just a forward of the focus ring, and we'll do another test here to see if we're located on the nodal point. We're centered right now in the center of the screen with our dowel rod to the far target. Let's pan to the left. And as we pan to the left, we still see some perceptible movement to the right of the dowel rod relative to the far target. And as we pan back all the way to the right side, we see that the dowel rod moves to the left relative to the target, telling us that our nodal point is still forward of the center of rotation, which is a bit of a problem in the fact that I'm now at the maximum travel on the Gigapan. I believe the Nodal Ninja and the Really Right Stuff products give you a greater degree of freedom of travel than the Gigapan does. Also, some folks have bought aftermarket slides to allow them to have greater travel on the Gigapans. What I've done is I've discovered that there's a little plastic stop on the Gigapan as a safety stop, that if you reach up in the front, at the very front of the slide, and push up on that plastic stop, you can overcome the safety stop and you can actually slide further back. So for a 24 millimeter setting, having used this process before, I already have a mark made on my slide that tells me where that point is at. I tighten the thumb screw back down here, get it set so it doesn't move around. And I know that for this particular lens at 24 millimeters, that mark is the ideal spot for this lens. If I reposition my camera so that it's on target to the dowel rod and the far target at the center, now as I pan to the left and watch the dowel rod, I'm at the extreme far left of the travel. The dowel rod is still very well centered on the target. Moving to the left, to the right with the pan, as far as I can go, it still stays centered. So we've now identified for the 24 millimeter setting the ideal nodal point for this particular lens. And as you can see, it's very far forward. One of the things I've done in the past is I've looked up on the internet for various lenses, and you can find tables that tell you approximately where the nodal points are for a particular lens camera combination. And in many cases, I've found that particular tables are not that accurate. I don't have one for this lens, but I do have one for my 70 to 200 millimeter Canon lens. And the nodal points those tables list for that particular lens are nowhere close to where the tables indicate. I'm going to zoom now to a tighter shot on my lens, and we're going to look at where the nodal points are for other settings. We're going to go to 35 millimeters. At 35 millimeters, with the nodal point set at the spot we had it set for 24 millimeters, we're going to do a check now and see how well we're centered on the dowel rod on the far target as we pan far to the left. And what we're seeing is a little bit of movement. And the thing we're seeing that's interesting that we didn't see before is if we look very closely, we've panned to the right and the dowel rod has moved slightly to the right. We come back to center here and is back on center. So this goes back to our rule of thumb, where we said if the dowel rod moves in the opposite direction of what we pan, in other words, if we pan left and the dowel rod moved right, that the nodal point is forward of the center of rotation. Now it's moving in the same direction, which is telling us that our nodal point is actually behind our center of rotation, telling us we need to move the camera forward slightly. And based on past experience with this particular lens, you'll see that I've made a mark out here further back on my slide. And that mark is a mark I've made to indicate where I should be for a 35mm setting on the lens. If I move forward to the point where I'm on that mark and reposition the camera so I can actually see the dowel rod, we see that the dowel rod now is very well centered on the vertical line on the far target. Panning all the way to the left, watching the dowel rod relative to the target, far target, we see that it's actually staying very well centered. Now I'm going to zoom the lens all the way to 70mm and see where we're at with this. Checking the centering on the dowel rod to far target. We're very well centered at the center of the screen. And just as a reminder, it's important to do the alignment of the dowel rod to the far target with the target and dowel rod as close to the center of the screen as you can get it. So now I'm going to pan left and watch the movement of the dowel rod to the far target as we pan to the left. And we see some motion. The dowel rod has moved a bit to the left when we pan to the left. Again, telling us that our nodal point is behind our actual center of rotation. Our center of rotation is located just eyeball somewhere right about here. Our nodal point must be behind, to some degree, behind where our center of rotation is located, telling us that we need to move the camera forward a bit. Again, I've been working with this lens quite a bit, and I know where my point is for this particular lens. And I know for this particular lens that the nodal point at 70mm is right here at the maximum travel, original travel of the slide, about 115mm. Get it positioned there. Now let's go through our motion again, repeating our check for the centering of the dowel rod on the target. We pan to the left. The dowel rod stays very well centered on the target. Move all the way to the right, pan to the right. Dowel rod still remains centered on target. So for this lens, we've pretty much have completed the identification of the nodal points. One of the things I like to do is I actually make a table, print it out. I do the table in Excel, print it out on my printer, and I will list for my particular lenses and my camera and so forth like that, what the ideal nodal points are. So I have this ready reference table, reference point to go to without having to carry a notebook or anything like that. It's right here on my screen. So I've got it from my Canon camera with the Sigma to 24 to 70 lens. I've got a 14mm prime lens. I've got a Canon 70 to 200, and each one of these has a listing for various zoom settings. One of the things I've learned, as I discussed earlier, is that for in-between points, like in this case we found that the nodal point was at about 115 for 70mm. At 35mm, we'll note that there's not a lot of change in position of the extension tube here between 35 and 70. It moves maybe 1/4 of an inch. So if I was wanting to shoot at 50 millimeters, what I would do is I would eyeball in between the 2 points. So at 50 millimeters, I might move out here to just beyond the maximum 120 point, but not all the way out to the mark that I've got for 35 millimeters. So I don't know if you can see it there. There's a mark for 35 millimeters, 120, 115 millimeters is the 70 millimeter point. So at 50 millimeters, I'll slide it to a point approximately halfway in between. And that is close enough for what we need to do here. So just to prove my point, I'm going to leave the lens set at 50 millimeters with that point halfway in between. We'll center up on the dowel rod. Now we're going to pan to the left, and pretty much an indiscernible movement of the dowel rod relative to the far target. Panning all the way to the right. Again, no discernible motion. So that, I believe, completes the setup for the adjustment fore and aft of the camera. One of the things that we want to pay attention to is I often will use an L bracket to mount my camera, and that allows the camera to move sideways relative to the center of rotation. It's important to make sure that you are doing a centering of the center of the lens left and right relative to the center of rotation. An eyeball adjustment of that is perfectly okay. The other thing you want to do is make sure that your lens is centered vertically. So the Gigapan has adjustments visible here. You can adjust these thumb screws by loosening them up, and you can move your camera vertically up and down to adjust for the diameter of the lens. This happens to be an 82 millimeter diameter lens, and these scales here seem to equal half the diameter of the lens. So for an 82 millimeter lens, I adjust this to around 41. Tighten these thumb screws back down. Another way to look at it, there's a mark here and here on the Gigapan. You want to take a straight edge or an eyeball and look across and make sure that the lens is centered vertically on that line between these 2 points. The left-right vertical is not nearly as critical as the fore-aft is concerned. If you get the fore and aft set and get these guys within 3 or 4 millimeters, you're not going to notice any degradation of your photographs as you do that. So I've changed over to my favorite go-to lens for doing Gigapans and panoramas, which is a 70 to 200 millimeter 2.8 lens. I love using this lens because at 200 millimeters I can take Gigapans that can be blown up to wall mural size and still retain the detail equal to a typical single frame photograph taken with a 5D like this. I've shot images up to 150 images in one shot, in one image, using this method and 200 millimeter lens, and gives excellent results. One of the issues that I've ran across using this particular lens, as I mentioned in an earlier part of the video, there's often tables available telling you where the nodal points are for the lens. And where I've got this lens set right now, so that the center of rotation is approximately 1/2 inch behind the mounting point on the lens bracket, is where the tables I've found in the past tell me the nodal point is at. I've found that information is totally wrong as I've done these experiments like this. So I've got this set up right now with the nodal point, or with the center of rotation centered on that theoretical nodal point from the tables, and we'll take a look at this and see where we're at. Got the lens set at 200 millimeters, and I've centered up on the dowel rod target, and if I pan to the left, we see that the dowel rod moves to the left also, telling me that the nodal point is behind this position that I'm at. Panning to the right, all the way it moves to the right. So that's telling me I need to move the camera forward. I'm going to demonstrate a little technique here that's kind of handy for finding the initial point, because right now I'm going to assume I don't have any idea where that point's at. I just need to move back and forth. So I'm going to loosen this bracket or thumb screw so that I can move my bracket back and forth. And as I move the bracket back and forth, I'm going to look at the dowel rod position relative to the target. So if I move the camera backwards away to the rear of the center of rotation, the dowel rod is actually moved further to the left. If I move it forward, we see that it's actually starting to move back toward the target line. So I continue to move all the way forward. I see that the dowel rod is now pretty well centered on the target. Now, what that's done is move the camera all the way forward as far as my sliders can go. It's put all this cantilevered weight out here on the front of the Gigapan, so it's tending to cause the Gigapan to want to rotate downward. In order to get it back to center, I'm actually going to have to move it up a little bit probably. Now as I pan to the left, to the right, back to center, the dowel rod stays centered. And as I go pan all the way to the right, it still stays very well centered. So what that's telling me is that for this particular lens at 200 millimeters, I need to position my slide at the 0 point. Don't particularly like that, not much I can do about it. Note also that I've got the camera mounted to the Gigapan, directly to the camera mount, not the lens bracket, which is more ideal. Most of us as photographers, we mount a long lens like this by its bracket so that we have the weight centered over the top of the tripod. This particular case doesn't work if we want to be on nodal point. I'm now going to zoom the lens out to 70 millimeters and check to see where my nodal point ends up being at 70 millimeters. Based on experience with the Sigma lens, we expect to see a significant change in the nodal point. So as I check my alignment, center up a little bit on my screen here, the dowel rod is perfectly centered. I'm going to pan to the left. I'm still at the 0 point on the Gigapan slide, which is where we were for 200 millimeters. As we move to the left, we see that the dowel rod moves significantly to the right. That's telling me that we need to slide the camera back some, so I'm going to do the same technique I did earlier, where I slide the camera while observing the dowel rod. And so now we're slid back. The dowel rod is pretty well centered onto the vertical line on the target. And what we see now is we're all the way out here to 100 millimeters on this slide. That's a huge change in the nodal point. We've moved from clear back here out to here. So this is a thing that makes us have to be keenly aware of our zoom setting as we set up. If I'm going to use this lens at 70 millimeters, I know that I've got to change position dramatically compared to what I use it at 200. Check my settings here and move to the center. Dowel rod still stays fairly well centered. I pan all the way to the right. Dowel rod is actually moving, and I'm set at about 100 on the scale. Moving back to the center. Just centering up on the whole system a little bit here. Now let's pan to the right. The dowel rod moved somewhat to the left. Panning all the way to the left, the dowel rod is moving a little bit distinguishably to the right, telling me that I don't have it set perfectly. Let's go back all the way to the right over here. I'm going to loosen my thumb screw just a little bit, move a little bit further outward. And that looks fairly good. Let's pan back to the left. Centered up, it's very well centered. And pan to the left, it still stays centered. Having worked with this particular camera in the past and lens combination, and I'm looking at my table here, I know for 70 millimeters that I've actually determined that 115 is pretty much the ideal setting. So I'm going to move to 115. And referencing to the target point there, to the dowel rod, it's very well centered. If I pan all the way to the right, it remains quite well centered. So what that tells me is there's a significant change in the nodal point position for 70 millimeters versus the nodal point position for 200 millimeters. Very important at that point to maintain a setting for the in-betweens, and I have a table here that I've done that with. I want to demonstrate a couple of those points. I'm going to go to 100 millimeters on my zoom and reposition. And when we get to the point where we start to see the dowel rod on the screen here, we see that the dowel rod is slightly to the left when I'm panned to the left. If I pan all the way to the right, it's moved to the right, telling me that my nodal point is backwards of my center of rotation. Referring back to my table for a moment, my table shows me that 90 is the ideal point. So if I adjust this to 90, we're now able to see that the dowel rod is very well centered on the target. Pan all the way to the right, it stays well centered. Now if I zoomed to 135, I would expect that to change even more. And what I'm going to see here as I do this is that this change is not exactly a linear change. One of the reasons it's important to check your lens for various points in between is that the change in distance for the nodal point versus the zoom setting is not the same. 135 millimeters changing from 100 to 135 versus 100 to 200 is only a 35% change on the lens setting. But at the same time, what we're going to find if we look at their table here at 135, it's telling me that 47 versus 90 is my point, which is exactly halfway. Not totally intuitive. You would expect it to be maybe 35% of the way between the 2 points, but it's not. If I go in and recheck my positioning, I'm centered on target. If I pan to the left, dowel rod stays on target. Pan to the right, dowel rod stays on target. So in a little bit of a review, we're finding that as we change our zoom settings on this particular lens, the nodal point changes significantly. For your particular lens, you need to check it at multiple points along the zoom range and highly suggest you make a table like this that allows you to quickly look it up. For the in-between points between those various settings, a eyeball guesstimate or estimate of the difference between, like if I was going to go from 70 millimeters to 80 millimeters, I would find that somewhere between 115 and 100 millimeters would be okay, kind of average in between. But for larger changes in zoom settings, obviously you're going to make sure that you're on the right target. I've changed over to a 14 millimeter lens. I enjoy using this lens quite a bit for doing astrophotography, night photography, and occasionally use it to do gigapans, and it allows me to do 360 degree or 180 degree views of the night sky with a gigapan type process. The 14 millimeter lens gives you about 120 degrees field of view horizontally, about 85 degrees vertically in a landscape orientation. The 14 millimeter changes the process just a little bit. You'll notice that I've moved the target to within about 1.5 feet of the camera. First off, it's very hard to even see the change of nodal point position with it positioned where I had it for the longer lenses. Here, because the dowel rod is so close to the lens relative to the target, it appears much closer together and allows me to be able to discern the change. One other thing you'll note on this is that normally I would use an L bracket to mount this. You may see some evidence of the gigapan here, but for doing nodal point adjustments, I don't need the L bracket. When I do the L bracket, I would have to adjust my vertical slide here to move the camera down a little bit further to allow for making sure that the camera is moving on the horizontal center of axis here. Let's get started. Move the camera around to the position to allow us to start looking at the nodal point. We have here now the dowel positioned pretty close. Let's see if I can tweak it just a little bit here. So we've got the dowel rod centered pretty well on the vertical line of the target down there. As we pan left, we'll see what happens to the dowel rod. So we're panning left and it's moving right significantly. We can see that change of position very readily. We pan back to the right and we see a significant change there. So we're centered up on the target. We're going to pan to the left and see where we're at as far as change in nodal point. Panning to the left, the target moves significantly to the right, and as we pan to the right, it moves to the left. So that's telling us that we're definitely off target. We'll loosen our thumb screw again, start adjusting it, and the rule of thumb is that the nodal point was ahead because of the change in position. So I'm moving the camera backwards relative to the center of rotation until the dowel rod is centered on target, and that looks pretty close. If I pan back to the left, watching the dowel rod relative to the target, it still moves a little bit. And just for the grins here, I'm going to check my reference. And typically what I've found in the past for this particular lens is that about 95 is the ideal point. I'm not quite at 95. I'm going to go ahead and move back to a true 95. Recheck my settings. Now I'm perfectly centered on the dowel on the target. So I pan to the right to center is centered. Pan to the left. It's changes a little bit. One of the things I have noticed about this particular lens, and I don't know if it's the distortion of the lens, but the left versus the right side pan doesn't necessarily remain true. If I set it somewhere halfway between, I was about 85 before, I'm going to go to 90. Let's see what happens as we go left. It moves to the right just ever so slightly. If we pan to the right and get to the extreme over here, it stays to the right just a little bit. So it appears that maybe my previous check on this particular lens didn't necessarily yield a perfect nodal point at the 95 setting I had before. It might be more ideally 90 as I've got it right now. That pretty much completes my demonstration. Hope you enjoyed. Thanks.